Question 13b. A solid of revolution is to be found by rotating the region bounded by the x-axis and the curve y equals k+1 in brackets times sine of kx, where k is greater than 0, between x equals 0 and x equals pi over 2k about the x-axis. Find the value of k for which the volume is pi squared. The volume V of the solid of revolution with respect to the x-axis is given by V equals pi times the integral from x equals a to x equals b of y squared dx, where y is equal to k+1 in brackets times sine of kx, a is equal to 0, and b is equal to pi over 2k. Now the integrand is y squared, so we need to square this function y equals k+1 sine of kx. So y squared is equal to k+1 all squared times sine squared of kx. Hence, the volume V is equal to pi times k+1 all squared times the integral from x equals 0 to x equals pi over 2k of sine squared kx dx. The next step is to express sine squared kx in terms of the cosine of a double angle in order to integrate. Recall that cos of 2a is equal to 1 minus 2 sine squared a, and in this case a is equal to kx. Rearranging this equation to make sine squared a the subject, we get sine squared a is equal to half times 1 minus cos 2a in brackets. Expressing the integrand in terms of cos 2kx, the volume V is equal to pi over 2 times k+1 all squared times the integral from x equals 0 to x equals pi over 2k of 1 minus cos of 2kx dx, where the volume V is equal to pi squared, which is given in the question. So performing the integration and forming an equation, we get pi over 2 times k+1 all squared times x minus 1 over 2k times sine of 2kx from x equals 0 to x equals pi over 2k is equal to pi squared. Next, I applied the limits of integration and divided both sides of the equation by pi over 2. We get k+1 all squared times pi over 2k minus 1 over 2k times sine pi is equal to 2 pi. Note that sine of pi is equal to 0, so this term here becomes 0. So the equation becomes pi times k+1 all squared over 2k is equal to 2 pi. Multiplying both sides by 2 and dividing both sides by pi, we get k+1 all squared over k is equal to 4. Multiplying both sides of this equation by k, we get k squared plus 2k plus 1 is equal to 4k. Subtracting 4k from both sides, we get k squared minus 2k plus 1 is equal to 0, which is a quadratic equation, which factorizes to k minus 1 all squared is equal to 0, since it's a perfect square. Taking the square root of both sides and solving for k, we get k minus 1 is equal to 0, therefore k is equal to 1.